next speaker in Pierre Trudeau, president of Positron Access Systems. He's a seasoned network and technology executive and board member with, wow, how can you have 35 years of experience? You look too young. Pardon?
That's good hair, that's all.
Okay, well, I'll let you jump into your presentation because you're going to a little bit about G.hn, I believe.
Thank you, Ken. Thank you, everyone, for showing up this morning after a social night last night. So a little bit of the same topic as Paul in terms of there's an MDU gigabit challenge and actually an opportunity. And you'll hear a little bit of how we do it on the G.hn side of things. And we have a little different approach on how we fit into the rest of the network. Recently, I was talking to one of our customers and they said, well, okay, I said, why did you pick G.hn? You have other options. GFS was an option. MoCA, in their case, they wanted to use a twisted pair, so MoCA was not an option. And they said to us, the first criteria when we pick a technology is IT integration. If I need to invest in IT, it kills the projects 9 times out of 10. It's just too much work. And that was someone that came from a large tier 1 that had moved into a up-and-coming, got him a large tier 3 in the US through multiple acquisitions. So private equity, acquiring a lot of small regional operators and trying to come on to some, I guess they can aim to be a tier 2 eventually. And they had to integrate a lot of different systems through this acquisition. And said, when we were the tier 1, we were in monopoly, we could throw all the money in the world into the problem because we knew that we had a captive set of customers. Now that we're more of a broadband service provider and with a regional focus, trying to expand our network coverage, we have to optimize our variable cost, which means each time we add a new customer, we lay fiber down this road, we need to be extremely agile. So we need to have systems that play very nicely together. We don't want to change how we do things. And what drove them is they had decided that we go with PON. A little bit of G.hn early on, and now they've been doing XGS-PON for probably a year and a half. So they did all of the investment needed to make everything fit into a PON world, which is great. PON simplifies the access network. Forget about amplifiers and repeaters and remote DSLAMs. It's just simple fiber split, very nice and elegant. And so in doing that, it gives them a better power budget all in all, and affords them to say, we can put enough smarts on the edge of the network, GPUs, G.hn access multiplexers, and so on. So we'll see how that plays into a over-encompassing approach to the MDU opportunity. So we'll talk a little bit about HN, fiber to the extension point, and so on. You've heard me present some of these things before, and that was when we said we will do the following. Now we've done it, and we'll share with you how that pans out. G.hn is used to address this problem where you have MDUs, fiber everywhere, but they cannot be efficiently connected. With G.hn, you can light up any MDUs. And it's the same process, the same backend, whether you use G.hn on telephone pairs or on coax. And coax can be point-to-point or point-to-multipoint. So operators like that because they can fully utilize what is in the MDU, not with having to decide, do I go with this technology or that technology? It's always G.hn. So that really simplifies the overall deployment and operational cost. So HN is an ITU-T standard. Paul covered a lot of the basics. What's important is Wave 3 was ratified 4 years ago, almost to this day, and chipsets are coming that will allow 10 gigabit on coax, 5 gigabit on twisted pair. There is great CDTA and IDTA on coax, and I don't know where you got your results, Paul, but because we have a lot of customers that deploy HN with multiple pairs in the same cable binder and consistently get 950-ish megabits per second, even when there is multiple active customers. And Vector Boost needs sometimes to be updated. You can go to a very basic reference design. What's nice with Vector Boost is you can augment how you decide to balance out the crosstalk mitigation, the time slot allocation to be extremely responsive to changes in the dynamic of the traffic, because as we know, it changes all the time. So vector boost is very efficient. And if you had, the vectoring on GFast was about 1,000 gig, we get about 95% of that, so 950 meg on G.hn, which is far sufficiently high that no one really cares. Rate and reach, this is one extra thing that we have on G.hn. If we have two copper pairs, and it's the case in North America and a few other markets, we can do MIMO. We all heard MIMO with the wireless guys, Wi-Fi and all that. So we can divide the 200 megahertz of spectrum over two pairs running at 100 megahertz. What that gives us is about almost 2 times the reach, because it's far less attenuation running at lower frequency range. The other thing that is important with vector boost is we only allocate the upper section of the spectrum when needed. So for subscribers that don't need their full gig, we don't give them the extra spectrum in the higher range, which means that there's a lot less crosstalk in that range and therefore better performance. So instead of always occupying 100% of the spectrum, we just occupy the portion of the spectrum that is truly required. When we go on coax, the blue line is RG6. And we go really interesting distances. We can do a gigabit speed test at 800 meters. We have our hard line like in RG11, we do that at about 1 kilometer. But then on the good old cheap, low quality RG59, we do this at 300 meters. So most of the time in an MDU, the coax runs are not that long, but we have done cases where we do garden style homes, as they call them in the US, rows of townhouses, where we can repurpose the coax that was laid by the cable operator. There, the distances do matter. So TR419, fiber to the extension point, is a great concept. It's all about reusing the copper or the coax, bring fiber close enough to the building, into or at the vicinity of the building. Great concept. The problem is in TR419, there's nothing that says this is how you define a subscriber and services. How do you activate? How do you manage them? How do you bill for services? How do you do analytics? So instead of reinventing the wheel, I said, well, hold on, PON got that figured out a long time ago with G.hn and now XGS-PON and 25 gig PON and 50 gig PON with OMCI. So if you do the fiber extension with HN, TR419 as a concept and OMCI, suddenly you have a very complete model that doesn't need any changes on the back end. It's just a very elaborate media conversion process. It's not a completely different technology. So you saw a similar picture from Paul. So you have an OLT with its CMS, whatever brand, and operators that run multiple OLT platforms will pick whatever EMS that they prefer, in-house, third party, this is BSS, OSS. What's important is the way you serve a single family home or a multi-dwelling unit is the same in terms that all you need, we created a 24 subscriber ONT on a stick that has XGS-PON termination with OMCI, and then that programs the GAM. So out of the box, you have a device that gets recognized by the network, can then be provisioned with all the subscriber information, and then deliver those services over G.hn. Here we're showing coax. It could be also on telephone pairs. And we have some of our products outside there if you want to have a look at what they look like. In terms of coax operation, DOCSIS has been pushing the DOCSIS 3.1 iSplit as their alternative to address the upstream limitation issues that they have. So they repurpose up to 204 megahertz as the uplink, which is great. Gives them about 1.5 gig, but they'll serve 100-ish customers there, a little stopgap, and then you have the downstream channel portion and also the whatever cable TV channel. So you start at channel 30. There's not much left below that now that DOCSIS operators are switching to iSplit. When we look at G.hn, we do 5 to 200 megahertz, pretty much the same bandwidth, a little more efficient encoding because we can do OFDM throughout the whole spectrum. So we get 1.7 gig aggregate, but then we don't care what happens above channel 30. Do whatever you please there. Use it for traditional QAM, cable TV, and so on. And what that does is it gives a lot of bandwidth, but the 1.7 gig throughput, where we can easily do a gig of upstream, is on a per port basis or per coax segment. We can serve up to 16 subscribers. And we do that when we do hotels like here. Because if you get 100 meg to your room, you're ecstatic. In MDUs, we should do a split 1-to-4, 1-to-6. Sometimes we go higher. It depends on the oversubscription that the operator likes to choose. But we deliver a lot more bandwidth than DOCSIS. And what is nice is as we have a multi-port GAM, we can fill up the full uplink capacity, whether it's XGS-PON at 10 gig, could be a fixed wireless uplink, could be G.hn at whatever the technology, we will always utilize the full uplink capacity, which is important as you build out your network and look at provisioning everything. And the way we allow cable TV content, we don't care about DOCSIS because when someone decides to use G.hn, they don't use DOCSIS. And DOCSIS can run alongside on the other coax going to a different apartment without any concerns because everything is always home run in MDUs. In hotels, you have daisy chaining, splitting over the vertical or horizontal axis, but that's fine. You get a common technology. So we do this in MDUs, we do this in hotels where the cable TV feed is really the output of an amplifier. We take an HN port, a low-cost combiner, and then we can go on whatever split chain. And in this case here, we're showing where we have still cable TV coexistence with G.hn. And as you transition to IPTV, usually we remove the splitter. That's our 2-port endpoint. So we have a second port, we go straight to the set-top box, a smart TV. And there's a very easy transition from QAM to IPTV. And as we do this, especially in hotels, they like this, they do one room at a time. They don't have to take down any section of the hotel. Whenever a room is free, they can do the upgrade, takes 15 minutes, and then move on. So they never lose any kind of revenues. So now let's talk about PON. I don't know how many times the word PON has been mentioned here, and it's a great approach. What we've done is, that little stick there, we picked the max linear solution because what was important to us, it had multiple TCONs, multiple XJAM, and it had a great way to map them together so that we could behave with G.hn the same way as a standard ONT operates, showing 24 PPTP unis. So in doing this, suddenly it makes it extremely easy to expand or build upon the XGS-PON investment that was made some time ago, or even G.hn, because there's no change, anything that is northbound from the OLT. It operates exactly the same way. We just operate as a media conversion with obviously the width to be able to optimize how the existing wiring is reused. What we did is we worked with Calix as our first implementation. And there we said, okay, we have a challenge that OMCI was not defined with the notion that a PPTP uni could be beyond another layer of passive splitting. So you have the PON splitter, one leg of fiber enters the building, you have a GAM, and then one coax port can be further split up to 16 ways. So you cannot address a PPTP uni by its port number. You could if you're on copper because everything is point-to-point. When you run on coax, you have to take into account that there's a splitter. You have no way to tell on which leg of the splitter you are. It's all passive, same as PON. And the way you can identify a service is by the endpoint device that converts G.hn back to gigabit Ethernet. And that as a MAC address, pretty much like an FSAN. So what we created was an association in a new managed element. You put the endpoint MAC address, think of an FSAN, and the ME instance for the PPTP uni. And now suddenly you can marry the subscriber and its services to a specific endpoint device on the coax network At that point, you have the full seamless provisioning, activation, monitoring of the services. Very straightforward. And we're considering working with Calix and MaxLinear on providing a proposal to the ITU to expand on the G988. So what happens under the hood? So a GAM is an Ethernet switch. We have an ONT SFP plus that handles all of the OMCI protocol. And then we have a number of endpoints. Point to point, point to multi-point, doesn't really matter. The most difficult thing is in the uplink direction, in the upstream direction, because we have one optical interface up to 24 subscribers. So we need to make sure that we deal with contention, that we deal with transfer opportunity management and so on. So we have to do two things. First, make sure that every G.hn subscriber doesn't exceed whatever bandwidth profile they are assigned. And that is a collection of sources. So you have a gig for best effort internet, 20 meg for IPTV, meg probably for voice over IP, because that's probably the smallest increment that you can define. So you have to make sure you manage all this. You can prioritize different services. You can isolate them with VLAN, single, double VLAN tagging, keep the VLAN, renumber the VLAN, the works. As we look at classifying, so we first make sure that the service assigned to a given subscriber, whatever quota is not exceeded. Then as we look at the sum of all these subscribers, you need also to manage that properly as you go with the up to 10 gig uplink to the OLT. And you need to present the data in a way that the OLT understands, so using the right T-cons to make sure that then the OLT will allocate the different bandwidth to all of the ONTs on the same optical link and grab the upstream traffic dealing with contention. So we make sure that we drop any traffic that would need to be dropped. We drop it at the GAM end of the network, of the link, sorry, to make sure that there's no lost bandwidth on the fiber link. In the downstream direction, it's a little easier. So some OLTs will do the rate limiting themselves because they see the traffic before we do. But might as well drop it there if you have to drop any traffic. In case the OLT doesn't do that, we can do the same enforcement. So in the downstream bandwidth, so in the downstream direction, we again take it from the T-count, map it with the XGen, the VLANs, look at the P bit, and then we have 4 queues per subscriber, not per port, per subscriber. And that way we can prioritize the traffic accordingly and really reflect the intent of how the queuing, the QoS is done by the OLT. We don't have to change the rules. We don't have to modify how things are doing. The whole planning for over-provisioning and all that is applied exactly the same way. So let's talk a little bit about the home grid versus MoCA and GFAS. Paul gave you some views, and let's have a different look at things. So what we've seen is it's not about the raw bandwidth. It's about how do you allocate the bandwidth, especially on coax, because there in the point-to-multipoint scenario, you have to really, you don't worry about crosstalk, but the management of the transmit opportunities is critical. And users are never equal. You can assume that they're all equal and give them the same kind of percentage. What we saw is by default, the HN chipset wants to be nice to everyone. You have 10 users on the same coax, they all get 10% of the transmit opportunities. And then it's up to the endpoint to say, I'm done, I don't need the all transmit opportunities, give it to somebody else. So by default, that can give a lot of latency. And MoCA does have the same behavior. Thankfully, G.hn exposes the transmit opportunity management APIs. And by using the active reporting from the end user, so whether it's on copper or coax, the endpoint always reports, I need this much bandwidth. It's not estimating, it's actual traffic measurements that is provided by the end user so that the GAM can figure out how to balance things out. As an example, we did a hotel project in Barbados and really, really crappy coax. We got it to work. Everyone was happy. They said, okay, let's bring up 16 rooms, IPTV going. So 7, 8 meg, let's call it 10 meg of throughput. And then they said, okay, let's do a speed test on one of the rooms. And they were getting, well, 16 IPTV flows, 160 meg. So they should have been, there was about 1.5 gig left of useful throughput. They were getting about 400-ish megabits per second. So hold on, what's going on? And then that's when we understood the default operation of the transit opportunities and the fact that everyone was relinquishing what they did not need, created a lot of latency and jitter. By optimizing the transit opportunity allocation, to recognize that not every users are equal at one point in time. Over time, everything usually evens out. Now we consistently get gigabit speeds or 2 users at 500 meg and everybody else has the same base services, no pixelization, no traffic loss, nothing. So that was a function of transit opportunities and also how many packets per second you can handle, because the traffic mix can be very different. G.hn doesn't care about traffic mix. Throw 64-byte packets in both directions nonstop, you fill the pipe. You get 1.3-ish in one direction, 1.7 gig aggregate, 800 meters, nothing to worry about that. So ask yourself when you look at the technologies, can the other technologies do this? And here I was just explaining about the transit opportunity management. As you balance out the traffic dynamically, you need to make sure that it's done optimally. And it has to be done by the GAM. There's no way, you don't want to set thresholds to say, well, we think the mix will be this or that. It changes all the time. The other thing is latency. 2.5 milliseconds is what we measure consistently over any type of traffic patterns, over any number of split. So that's important that you understand that. And then we can still burst to a gig, no problem. So it's not just about the bandwidth. And when I was looking to illustrate speed, I said, oh, I'm in Germany, Porsche 911, and it just happened to be that there's a new edition that came out recently about the legendary Dakar race. This is an extremely versatile car that can drive fast and efficiently under any road condition, whatever you throw at it. And sometimes other technologies look like this. A dragster that is great on the straight line for a quarter mile, and then the engine may blow up. So G.hn gives you a lot more predictability and stability in terms of your performance. So what we've learned from our deployment is it's important to be presented as an ONU with multiple PPTP unit, because what that does, it addresses the IT integration problem. Actually, there's no problem with IT integration. It just looks the same as what has been done over time with PON. And we reuse the wiring, coaxial twisted pair, and that puts the gigabit backbone infrastructure in the building that is good also for smart buildings, managed Wi-Fi, and so on. That is critical. It's not just about the internet access. It's about all of the services inside the building. The other thing that we learned is that the flow-through provisioning is done one of two ways, and it's a choice of operators. There's no way better than the other. You either do pre-installation provisioning, where the OLT already has all the bandwidth profiles and the subscriber definition, and when the endpoint is attached, the user is provisioned automatically. Some other times is you first install the endpoint, verify that you have the optical link to the GAM works, and then that you have a G.hn link up to the GAM, and then you tell the backend, okay, now please send me the profile mapping for the user on this endpoint, and that's all done through OMCI. So whether it's done pre or post provisioning, your solution needs to adapt to that. It's not, don't change the way services are deployed, you adjust to the way services are deployed. And maybe that's a task for the Broadband Forum working with ITUT, is to agree on how we expand point to multi-point mode as part of G988. We're open to share what we've done. It's working very well, very efficiently, and it could be made easily into a new standard managed element. So in summary, it's all about IT integration. What we found is bandwidth is a need. You need to be able to deliver a gig. Multi-gig, there's a big question mark when you look at the actual average usage. 30, 40 meg, maybe peaks of 100 meg. 25 gig PON, 50 gig PON eventually is great about capacity, not because you need a user with 50 gig into their home office. It's about capacity. Same with XGS-PON today. And G.hn gives you the ability to fully utilize the capacity to the building by having actually more capacity inside the building the moment you have more than 10 doors, which is the average MDU in the US is 2 to 19 doors is 65% of the market, and that's over 30% now of people living in MDUs in the US. The number keeps going up over the last couple of years. PON is important. You need to anchor the solution around PON deployment. So whatever operators decide to how they manage their PON, especially in a multi-vendor environment, you cannot force that it has to be this EMS or that EMS. You need to, as G.hn, we just work on whatever EMS has been put in place. And that also gives you the same technology on both copper and coax. And that's how you get the full end-to-end extension. Thank you very much.
Thank you, Pierre. We do have time for a couple of questions. I'll start while people come to the board. You're focusing, and you touched upon this just once or twice, but the whole user experience, and why do you think that's an important aspect of this, maybe over speed versus speed?
Well, how many of you have experienced bad Wi-Fi in their life? Right? It happens all the time. And when you're in an MDU, it's a three-dimensional chess problem almost. Especially in middle floor, you have neighbors to the left, to the right, upstairs, downstairs, across the aisle. So you end up having a very complex Wi-Fi management problem. So we're working with the leading Wi-Fi vendors. You will not see us having Wi-Fi in our endpoints because we believe we have to work with the best. Work with Aruba and Cisco and Ruckus and Calix and a bunch of others, because they all have their views on how they make Wi-Fi great, and they all do in one way or the other, and that's critical. And that's how you measure your connection to the internet. It's not about how good is your pipe into your living room. It's how good is my last 10 meters on Wi-Fi. So we need to make sure that we provide everything that leads to a great Wi-Fi experience, and that's what dictates everything. So IT integration is that much more important for the full user experience.
Yeah, I mean, this is how people are when they're in their place.
A phone, laptop, whatever.
Wi-Fi, right?
Yeah.
Laptop. So then the question is, are there alternatives to OMCI integration as far as, getting the flow through provisioning and activation? I mean,
we're working with some of our partners to say, okay, if you have a large MDU, I don't know, call it 100 doors, 200 doors MDU, PON may not be the right or the optimal technology in terms of cost, because you would dedicate a PON port to a single MDU. It kind of defeats the purpose of having the passive splitting and all that. And having an active fiber may be a better feed. Or it could be a case where it's fixed wireless. So what we're doing is we're working with some of our partners to say, you already have done BSS integration. So can we agree on common API, whether it's a net configuring model, PR369 with USP, that allows us to extract that information and bring it to the GAM. So whether it's OMCI or other standard, you would achieve the same result. But it's like, again, don't change how you present yourself to the BSS. Don't change how you present yourself to anything above the optical switch, for instance, or the wireless radio, because that creates IT integration work, and that's never a good word. It's almost a four-letter word in the space, right?
It's a lot of friction to get that through the
Absolutely.
systems, isn't it? And then it sounds like you're also planning on making a contribution to G.988 as far as...
We're discussing that. Obviously, we'd love to do that. We're a bit new with the ITUT, so Maxine has offered some assistance in doing this. So we're willing to share that, but we also have other ways that we're working on to make sure that we don't have to be dependent on OLT vendors to upgrade their firmware to work in a point-to-multipoint scenario and still have the seamless go-to provisioning. So we're about to announce some different methods to do this, but we love the fact that if we can do everything under the G.988 umbrella, obviously it makes this very well supported standard. We like to play with standards.
And you touched upon 10 gigabit, that there was some sort of roadmap. I mean, I think early in the presentation you said.
Yeah, so ITUT in March 2020 ratified Amendment 3, or Wave 3, I always call it, and it does 10 gig on coax and 5 gig on twisted pair. So the coax will go to about 1.3 gigabits. And it was proven with DOCSIS. Yesterday, we had someone from Cable Lab sharing that DOCSIS today runs up to about 1.3. DOCSIS 4 gets 10 gig. And there's plenty of spectrum left that we can go to 100 gig on coax. Before we exhaust the capacity of coax in terms of bandwidth, we have a long way to go. This appears a bit more challenged, but it's still, we can definitely get 5 gig without any concern. So we're working with MaxLinear. I'm not going to put dates on behalf of MaxLinear. Please ask them. We hope that it's not too far out. But as we look at 10 gig, suddenly you say, well, okay, let's say tomorrow I have 10 gig on coax, and I have only XGS-PON or 25 gig PON to the building, it may be borderline in terms of the ratio of bandwidth. So we believe that 10 gig on G.hn will probably align with 50 gig on PON in what, 28? That's about the time that people were predicting that when that happens. And I think those will be a perfect companion to go to the next step of bandwidth to the user.
Super. Well, Pierre, appreciate your presentation. Let's give a big hand. Oh, does Mauro have? Oh, Mauro has a question.
Good morning, everyone. Mauro Tilocco with Team Telecom Italia. As I've been inspired by your last slide, where after your speech on optimizing, giving the best not just bandwidth but quality, you talk about the integration with the management system. So clearly, the file layer technologies in different segments, especially the access domain and customer premises, are a big deal with respect to the overall quality of experience. So I don't know if you have thoughts and fruitful thoughts about how to, on one hand, making the file layer technology work in a mixed way, in a seamless way, and silently optimizing the job that they're doing in terms of bandwidth and latency on one hand, so ability to sort of self-heal and do a sort of behind the scenes job optimization, probably with AI. And also if you have any thought and idea on ways to also integrate the file layer with an overall SDN, softwareization of the network. So making the different layers, different resources collaborating together per, of course, a coordinating brain up there.
Yeah, so the question is, are we looking at AI or kind of advanced learning to optimize throughout? So we operate really under the guidance of the OLT, first and foremost. So we really make sure that over the PON segment, we are responding to the demands of the OLT, because we just fill up the queues and the OLT will empty the T count as it decides. So any optimization on that front, it really is on the OLT aspect. What we do is we're looking, I'll say, at making sure that we don't queue data that would get discarded by the OLT, because again, that's very counterproductive. What we're starting to look at is looking in partnership with the Wi-Fi vendors to say, what needs to happen on Wi-Fi in terms of your operation when you're inside your apartment? And if you move from your living room to your home office and you happen to be on different Wi-Fi devices, that's well understood, because you're behind your Wi-Fi router. And as far as the rest of the network is concerned, it's unaware, it doesn't have to care about that. But when you are inside an MDU and you leave your MDU, or a family member takes their mobile device and goes to a shared area in the MDU, a work area, the pool, the gym, whatever, suddenly you want to make sure that that bandwidth usage is still associated to the bandwidth profile that is in your apartment. Because you're on a 500 meg package, someone is on a gig package, whatever the mix of packages are. And it's also about the user experience. As Ken pointed out, if you sign up for security on your network, that the service provider gives you an antivirus package, cloud-based, gives you parental control, gives you other value-added application running Purple, for instance. You want all that to follow the device, but I call it the Wi-Fi bubble that needs to follow you, although that bubble can get spread quite a lot across the MDU. So there, we're working with Wi-Fi vendors to predict how we can improve the bandwidth allocation as you move from one access point to the other access point and give a consistent user experience. So that's really where we're starting to focus some of our activities beyond just gigabit Ethernet to each and every apartment or condo units in the building.